Hi guys, today we're going to spend some time learning about the periodic table and how elements are organized. Throughout the video, I'll be asking you to pause and color in areas on your own tables. For this process, I would have 7 different colors in colored pencil and 2 additional colors in markers. First, let's take a minute to learn about the information contained in each square on the periodic table. Every element has a specific square. Different periodic tables may have more or less information, but we'll stick with the 4 most important pieces of information. First, every square has the atomic number. This is the whole number. Every element has a unique atomic number, and we can use it to identify that element. You can think about it as an address on the periodic table. In our example square, we'll be working with gold, and gold's atomic number is 79. Next, each square contains the element symbol. This is usually the largest piece of information in the square. Gold's symbol is AU. Next, periodic tables contain the names of each element. Finally, you'll see a decimal number. This is the atomic mass. We'll learn in a couple of weeks that not every atom of the same element has the same mass, hence the need for an average. The first level of organization on the periodic table is into columns. Columns on the periodic table are called groups or families. And just as members of your family share characteristics, the elements in the same family also share characteristics. So for example, my brother and I are both blonde and blue-eyed and fairly short. We both use a lot of hand gestures when we talk. In the same way, elements in the same family will look similarly and behave similarly. Today we'll highlight 4 families on the periodic table. The first is in column 1A. They're called the alkali metals. Elements in this family include lithium, sodium, potassium, rubidium, cesium, and francium. All of these elements are silvery solids at room temperature. They're hard to the touch and they're highly reactive. When placed in water, they may fizz and spark or even explode. Take a minute to pause the video now and color in the elements in this column. Our second family is in column 2A, right next to the alkali metals. These elements, beryllium, magnesium, calcium, strontium, barium, and radium, are called the alkaline earth metals. They too are silvery, but they're less hard and less reactive than the alkali metals. Take a minute now to pause the video and color in this column. Next, we move to the opposite end of the periodic table, to column 7A. Elements in this family, fluorine, chlorine, bromine, iodine, astatine, and 117, which has recently been named tennessine, are called the halogens. These elements are highly reactive. Because of this, if they're ever alone, they immediately react with something nearby them, and so they're always found in compounds. Take a minute to pause the video and color the elements in column 7A. Finally, we come to the last column on the periodic table, 8A. Elements in this family are called noble gases. They include helium, neon, argon, krypton, xenon, radon, and element 118, which has recently been named oganesson. Unlike the halogens, the noble gases are unreactive. They're always found in their elemental forms, never in compounds. We can think about them as being noble or too cool to interact with other elements. All of the elements in this family are colorless, odorless gases. Take a minute to pause the video and color the elements in this column. Our next level of organization involves the rows on the periodic table. The horizontal rows are called periods. When we look at the periodic table, we see that properties repeat periodically, or you can think in a cycle, as we go across each row. This periodicity, or cyclical repeating of properties, is how the periodic table gets its name. So as we go across each row, first we see the thing that is silvery and very reactive with water. Then we see a thing that's silvery and kind of soft. We see some more elements. Then we see the thing that's so reactive it's never found by itself. And finally we see a thing that doesn't react at all. We move to the next row and we see the same patterns. a thing that's silvery and very reactive, a thing that's silvery and soft, some more elements, a thing that's super, super reactive, and then a thing that doesn't react at all. There are two other regions of the periodic table which I'd like to highlight today. First are the transition metals. These elements are found in columns 1b through 10b. We'll spend time later this year talking specifically about the transition metals. But here we find lots of common and precious metals like iron, nickel, copper, and zinc, silver and gold, titanium, and platinum. Take a minute to pause the video and color in all of the elements in 1b through 10b, or the elements you see colored pink in the diagram below. Finally, we have the inner transition metals. These elements are placed below the periodic table, but they should fit between elements 56 and 71, or between the alkaline earth metals and the transition metals. Because that would make the periodic table too big to fit on a piece of paper, we cut them out and placed them below. The inner transition metals have lots of unique properties, and many are radioactive. You may have heard of uranium and plutonium for their use in atomic bombs. Take a minute to pause the video and color in the elements of the inner transition metals. Another way we can think about the elements on the periodic table is by their metallic characteristics. You'll see on your tables that there's a zigzag line that stretches from boron, element 5, all the way to element 118. To the left of this line, all of the elements are metals. They are shiny, malleable, meaning they can be hammered into sheets, and good conductors of heat and electricity. Malleability is an intensive property. Along the zigzag line, we have metalloids. These elements include boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. There is not a good definition of metalloids. Scientists say that they have properties in between those of metals and nonmetals. Take a minute to pause the video and color in the boxes for these 7 elements right now. Finally, to the right of the metalloids, in this area here, we have elements that can be classified as nonmetals. They have opposite properties from metals. They're not shiny and they're not good conductors of heat or electricity. Finally, let's take a minute to look at the states of matter of elements at room temperature on the periodic table. Most elements are solid at room temperature. Mercury, gallium, and bromine, elements 80, 31, and 35, are liquids at room temperature. Take a minute to make a colored box around these elements or put a symbol in each of them. There are also several elements that are gases at room temperature. Hydrogen, nitrogen, oxygen, fluorine, chlorine, and all of the noble gases are gaseous at room temperature. You'll notice that most of these elements are nonmetals found to the right of the periodic table. Take a minute to put a colored box around these element squares or a symbol in each of their boxes. That's it for today. Please write down any questions that you have and we can discuss them in class soon.